Thank you. Uh, like he said, I don't know if he mocked me somehow because I know zero Spanish. My name is, whoops, technical issues, as usual. Where's my mouse? Full screen, there we go. So, like I said, my name is Miguel Palhas. I came from Portugal. Actually, we Portuguese sometimes are known, I've heard from a lot of people, that we are some of the most welcoming people in the world. And I gotta say, I found some really good competition here in Colombia. So thank you all, and thank you for the organizers for setting up all of this. I know in my skin how hard it is to organize conferences. Like I said, I come from more technical issues. I come from Portugal. This used to be our official flag, but you probably know us for our new one right now, which is this one. This is the only thing anyone knows about Portugal right now, unfortunately, which is a shame because we have a lot of good things to offer. But I'm not here to talk about geography. I'm here to talk about something that some people hate, some people love, a lot of people don't know anything about, cryptocurrencies. So who knows what this is? Okay, most people, as expected. And this one? A few less people. And any of these others? Particularly the one right there. Okay, so most people are familiar with these concepts. These are all cryptocurrencies, so essentially digital money that works on top of a technology called blockchain. I'm going to talk more about this later. If you haven't raised a hand at all, that probably means that you've been living offline for the past 2 years. And I actually envy you for that. This has been kind of a crazy world. Nowadays, there are hundreds of these. Some are cool ideas, interesting projects. Some are completely stupid ones. Like this does exactly what the name suggests, by the way. It was made as a joke, but it worked. It made money. But I want to distance ourselves from all of this and focus on the actual good parts of this, which is, for me, is the technology. And for that, I'm going to focus on Ethereum, which is what I'm studying, what I'm working on. And it's for smart contracts. It's not the only one that supports smart contracts, but it's by far the most famous one and the most supported. So we've talked really briefly about what cryptocurrencies are. Now let's see what the underlying technology, the blockchain, is. Anyone here can raise a hand if you have a general idea of how blockchain works. Even some concept or two, not the whole thing. Okay, so some people are familiar. That's good. That's going to make things easier. So I'm going to go through a lot of concepts, but I don't really have time to explain all of this because there's a lot of ground to cover. So if you have any questions about anything, just come ask me later. I'm free to answer them in English or Portuguese. So a blockchain, essentially, it's a fully decentralized peer-to-peer network. There's no central authority. There's no administrator of the system. It's completely peer-to-peer. It's an ordered list of transactions. The network keeps storing transactions that are kept in order, like you can think of it like a ledger that, in case of Bitcoin, it says who owns what, who owns how much money. These transactions are grouped in blocks. This is done for a few technical reasons, mostly. It's append only, so data is never deleted from the blockchain. You only append data. So if I'm sending money to someone, I'm not deleting my previous balance. I'm just updating the states, appending something that says, now I have this instead of that. It's unhackable, kind of. Nothing in this world is 100% secure. And like we saw yesterday, time is a really hard problem. And the way a blockchain solves the problem of time is by not having it at all. Like we saw yesterday, that's a really common solution. So in a blockchain, we don't have the concept of time at all. A transaction, or a block in this case, only knows the block that is before him and the block that is after it. And that's the only ordering that we have. We don't have the notion of what time the block came up. Actually, we do, but more for the outside world. Technically speaking, we don't care about that. And there are a whole bunch of other buzzwords that you probably heard about, like mining, wallets, elliptic curves, Merkle trees, proof of work, proof of stake, and above all, cryptography. There's a lot of cryptography around this whole area. I'm not going to talk about any of this. I'm just going to take all of this for granted and assume that whoever invented all these things, they did a good job and they work. And we're going to talk about the higher level layer. So if we had like a pyramid, we could say that at the bottom of the pyramid is the hardware, the network layer, so the computers that power the blockchain. On top of that, we built these consensus protocols, the things that ensure that data is stored in the blockchain, that it's propagated correctly, that data is eventually consistent across all the nodes. And on top of that, we can add a semantic layer that adds some meaning to that data that we have underneath, which we can then use to build distributed apps with Ethereum. Anyone knows what that logo is? Very few people, okay. That's called CryptoKitties. It's probably one of the few successful real apps done with Ethereum. You use it to breed cryptographically unique kittens and sell them online. Just a stupid game that earned a lot of buzz because it was built on a blockchain. And so smart contracts are in this layer. So we can pretty much assume that everything underneath works, is stable, and we don't need to really understand how it works. It's pretty much like web development. I would bet most of you know how to make an HTTP request, but very few of you would know how to make an HTTP request library, like using the actual network layer underneath to build it. That would be a harder problem. So all of these are taken for granted. If you have questions about it, I'm happy to answer them as well, but I'm not going to focus on them here. So finally, to explain what Ethereum is, or in this case, what makes it different from Bitcoin, I just have to go through one more concept, which is the concept of a transaction. So because of how the word is used and because of what Bitcoin actually is, you may be tempted to think of a transaction like this, like transferring money or value to another entity. But actually, a transaction, and we as developers, we can easily understand that a transaction can be more like this. So an update to some state, or actually, I should say, an atomic update to some state. So either the whole thing happens, or none of it happens at all. And this is actually the leap that Ethereum allows us to do. So instead of having just transactions that say, I'm giving this money to this other people, to this other entity, I can say the state was like this, now it's like that, and whatever meaning that state has is up to us. And we get all the guarantees that a blockchain supposedly gives us, like consistency, proving that the data hasn't been tampered with, that it's cryptographically secure. But at this point, most people ask, what's this for? What can we do with this? And it's a fair question and sometimes hard to answer. And the way I like to see it is that we can think of a blockchain as implementing or abstracting away the concept of trust. So we're always trusting other entities every time. We trust Facebook with our data. We trust our bank with our money. Most of the times it's okay. We know they're not going to screw up, or maybe they will. But we're still trusting them with our data or with our money. And in some cases, that can be an issue. And with a blockchain, you get all the benefits of trusting someone without having to actually trust them, if that makes any sense. So we can have those guarantees for free without giving away our data to some other entity that may tamper with it or steal it, for example. So a few possible use cases for this: economic systems like money, as we all saw. Bitcoin is the perfect example. But we can also think of things like insurance policies or any kind of written law or contract. So for example, we could have a blockchain system that automatically refunds you for your flight if it gets canceled or delayed, and you wouldn't have to trust your airline company to do the whole process as it should. And my favorite, something like proof of existence, where you could store something in a blockchain or just a hash of it, and that would serve as a proof that that data existed at that particular time and that you had access to it. So you could prove that you didn't tamper with that data by checking that the hash still matches or something like that. In some use cases, this can be particularly useful. And some people might argue that a lot of these use cases could be done without a blockchain, and that's totally fair. Actually, that's a whole huge philosophical debate that I don't want to get into right now. But let's just assume that the technology is useful. It may not be the world savior that some people may claim to be, but it's still a useful tool like any other. And now I've told you what we can do with a smart contract, but I haven't told you what a smart contract is, technically speaking. And what it is surprisingly a piece of code, as we should expect. It's a piece of code that lives on its own in the blockchain, and by this I mean that once you deploy it to the blockchain, you don't have control over it as an administrator or something. You can't delete it later, you can't push a hotfix or something. It's just a regular entity that lives on its own there. It's a first-class citizen of the blockchain, and I'm going to explain a little bit later why this is important. It keeps its own state. I mean, the state is kept in the blockchain, but the smart contract has a notion of what its state is and what it means. And it defines the rules to mutate that state. So the only way we have to change that state is by interacting with the smart contract according to the rules that were coded into it. So that's Ethereum. Now let's jump to Solidity, which is the smart contracts language that is used in Ethereum. Not the only one, but by far the most popular one, at least for now. And I should give you a fair warning. The next slides may be, if there are sensitive people in the audience, maybe please be careful, because some people see some resemblances of this code to Java. So I'm sorry in advance. So this is a smart contract. It has a contract called bank. It has a constructor, that same name as the contract. You can look at this and say, this is a class, same thing. And it actually is. The only difference is that they decided to change the keyword class for contract. But the concept of a class is pretty much the same that we have here. So in this case, it's just an empty constructor. Let's pretend that we're building a bank on the blockchain, so a smart contract that's going to keep some people's money, and so that they can later withdraw it. So we can add some state to the bank, some instance variables. For example, a name, just to give it a name, and then a mapping from addresses to integers. This is going to keep the balances that everyone has. So an address is a blockchain address. This is actually a type in Solidity. And we're going to keep a mapping, which is essentially a hash table of, for every address, how much money that address has. And so we can add the constructor later. We can pass in a name as an argument. The balances in Ethereum, everything is initialized to 0 by default, so we don't need to worry about that. Everyone starts with no money at the bank, which makes sense. And then we can start adding some functionality to this. For example, we can add a function to check what the balance is of a user. We pass in an argument, which is the address that we want to check, and we just get back whatever is on that field of the hash table. This is actually a pure function, which what it means is that it doesn't change anything in the state, it just reads from it. That's a keyword in Ethereum that just serves so that the compiler can warn us if we're trying to mutate state when we're not supposed to. And one thing that we can show here is that, unlike some people may sometimes believe, a blockchain, the data in the blockchain is not private. So you can notice that I can check the balance of any account. As long as I have the address, I can see how much money it has there. And this is a common misconception that data in the blockchain is private and anonymous, and most of the times it's not. It's completely public, everyone has access to it. It's not encrypted in any special way that only the owner could access it. But so this function doesn't change anything, it just reads from the state. Let's see how we change the state. So we can have a function to deposit money to the smart contract, and this has two particularities. The first one is this payable keyword, which is a kind of a weird thing to explain. So the way to interact with a smart contract is by sending a transaction to it. And we send a transaction where the data that we send along, there's a data field that we can change, has some data that tells the contract to call this particular function. And since it's a transaction, in Ethereum, we can send money or Ether in that transaction. So we can mark this function as payable to indicate when I call this function, I'm going to send along some money with it. And that money is going to be stored in the smart contract. It's going to be there unless he does something with it. So we get that for free. So we send money to this function, and that money gets stored on the smart contract's own account. And all you have to do is update the balance to say that whoever sent that transaction gets whoever value he included is added up to his balance. And so we update the state to be consistent with the money that we received. Then we can have a function to withdraw money, which is actually the only thing that was left. So we specify how much we want to withdraw, and we have the contract send through this transfer function. It's going to send back to me the amount I requested, and then it's going to deduct that from my balance. Does that look right? Anybody see a problem here? So the huge problem here is that I don't know if I have enough amount there to withdraw. So if I have 0 in my balance, I could still withdraw whoever I want. Since this is an unsigned integer, this would actually overflow all the way to the top, and I would have pretty much infinite money. So that can happen. And the way we do that is by failing early and failing hard. That's pretty much the philosophy in Solidity. We have this keyword require, where we pass in a condition. If that condition is not met, the whole transaction fails right away, really hard. The error messages don't even help that much. So everything that's either below or above doesn't matter. The whole function is a transaction. If a requirement at some point fails, the whole thing is rolled back. So we require that the sender has enough amount in his balance. We transfer it, and we deduct the amount from his balance. Make sense now? It does, except it doesn't. So does anyone know what a reentrancy attack is? OK, so I'm going to ask you not to answer when I ask the question, just to make it more fun for everyone else. This is one of the weirdest security issues that I've ever found. And to explain what this is, I'm going to tell a quick story. It's a very boring story about me going to an ATM. So let's say I go to an ATM, and I want to withdraw $1 million. So I put my card, I insert my PIN, everything is correct, and I ask for $1 million pesos. And the ATM is going to check my balance with my bank account. OK, you have enough. There you go. And then it asks me, do you want to do anything else, any other operation? And at that point, I'm like, OK, what the hell? Give me another $1 million. I'm feeling rich. And the ATM is going to check my balance, give me back my money, ask me again. This time I'm OK. I have enough money with me. So the ATM is going to update my balance with my bank, return my card, and off you go. Anybody see a problem here? Any small detail at all? So you can notice that I'm updating my balance right there. But up here, in these two sections, I'm checking for my balance. And so if I have only 1 million in my account, at this point, it's all good. I have enough money. It should give it to me. But at this point, it should forbid me from withdrawing money. But we haven't updated our balance yet. So the ATM is going to give me the money, and only then it's going to deduct $1 million from my balance. So this is not actually how ATMs work, by the way. Otherwise, we'd all be rich. But this is kind of how Solidity works, unfortunately. And so we have that exact bug in this code, and I can show you why. Let's say we have our bank right here, same function that we saw before. And now let's introduce another entity, which is this totally legit user that's actually another smart contract. And remember that I said that smart contracts are a first-class citizen. What I mean by that is that they are as much users of the blockchain as we are. They have their own address. They can interact with other smart contracts. They can do the same operations that we do. In the context of a blockchain, we and smart contracts are pretty much the same thing. They don't care. So we could deploy a smart contract, and instead of using the bank ourselves, we could have that smart contract call functions from the bank. So let's say we have a function called steal. That's going to the bank, and it's going to withdraw 100 Ether, or 100 Wei in this case. Let's assume that we have enough balance for this transaction. So what this is going to do, it's going to call back this function. It's going to withdraw my money. The requirement is going to pass. Everything is good. and it's going to transfer the money back to whoever sent it, which is, in this case, is the smart contract. And here comes the quirk. So in Solidity, or in Ethereum, I should say, like I said, when you're sending a transaction and calling a function from a contract is pretty much the same thing. So here, I'm sending a transaction to that smart contract. So in a way, you could say that I'm calling a function. But which function am I calling? I didn't pass a function name or any arguments. So what the Solidity developers decided was, OK, if we can't match the transaction to any function that we know of, let's just call it a fallback function. And that fallback function can be defined by whoever codes the smart contract. So what if I create a fallback function that just calls still again? So it's going to go back up here, and you can see this enters a loop. I actually would have to control here to make a stop, like a counter with a condition to make it stop after a while, otherwise it would go on forever. But this actually works. It's going to keep on looping and calling all, this whole loop all the time. And you can notice that the important part, where my balance is deducted, never gets called. And this very weird, very stupid bug, I should say, is how someone stole $60 million from a famous contract a few years ago. So if you ever heard of the DAO, DAO, there was a famous entity a few years back until they got stolen from about $60 million at the time. Since then, Ethereum has risen in value. And it just kind of died out. So it's a really stupid bug, and actually the fix for it is kind of stupid as well. So this is kind of the same logic we had: require, transfer, and deduct the balance. Anybody want to take a guess at how we fix this? No takers? So we just swap the order. First we deduct the amounts, and then we transfer it. We guarantee that we update our state however we need before we transferring execution control to another entity. And this swap would actually be the fix to that $60 million theft, just a swap of these two lines. This smart contract was actually, that one that got stolen was actually audited by the creator of Solidity, so even he missed this, which actually goes to show how horrible this language is right now, that it's so easy to make such huge mistakes. And yeah, I promised you kind of an introduction to smart contracts, and I just ended up rambling on about how Solidity sucks. The good news is that there are solutions being worked on right now. One of them is called Viper, that's meant to be a replacement for Solidity. Another one is called Plurus, which is from another blockchain project, Cardano. They're working on their own smart contracts language. The first one is done in Python, second one is in Haskell, so you get all that formal methods verification branch of mathematics that they usually use over there. But yeah, if you're interested in working in any way with smart contracts, Solidity is probably the way to go right now, but maybe these two projects are worth checking out. And that's all I have. Thank you.